Located at the University of California, Davis, the Advanced Research for Manufacturing Systems Laboratory, or ARMS Lab, was established to focus on manufacturing technologies, CNC machine tool design and applications, as well as machining processes analysis and development. The core objectives of the ARMS Lab encompass the following: to conduct practical research in order to contribute to society and industries by providing useful and relevant results to the field of manufacturing, where research topics must meet demands that come directly from industry. To develop a win-win relationship between the ARMS Lab and its fellow collaborators in order to promote and share technological advancements in the field of manufacturing. To give students the opportunity to be interested in manufacturing research and machine tools by providing access to state-of-the-art equipment, knowledge, and technologies. To educate researchers through lab activities involving not only academic work, but through experience and opportunities that lead to the development of a strong sense of personal responsibility as professional engineers. And lastly, to give researchers the opportunity to work with industry leaders through internships and educational training. The ARMS Lab was launched in January 2013 by Dr. Soshi. A fellow UC Davis alumni, Professor Soshi earned his master's and PhD from Davis from 2003 to 2009. While earning his PhD, Professor Soshi was also hired by Moriseki, where he worked as an engineer from 2008 to 2012, working on mechanical and mechatronic designs before moving to the production technology team, developing strategies and processes to reduce lead time and increase overall productivity related to machine tool construction. Professor Soshi's current research interests include manufacturing systems and processes, CNC machine tools, mechanical and mechatronic design and analysis, high-performance machining, and the advancement of production technologies. There are currently 3 full-time researchers working in the ARMS Lab. Nick Raymond received his BS in Mechanical Engineering from UC Davis in the summer of 2013. After earning his degree, Nick joined the ARMS Lab, where his knowledge and experience operating and programming machine tools has proven to be a vital asset. Nick currently works as a junior specialist in the ARMS Lab, working closely with Professor Soshi on ongoing research projects and assisting with day-to-day lab operations. Kevin Browers is one of 2 master's students currently working in the ARMS Lab. Kevin's interests include machine automation and applications involving high-precision manufacturing. Kevin's current research includes implementing subroutines with an abacus, the finite element program, that will allow the ARMS Lab to incorporate a machine tool spindle control system within pre-configured cutting simulations to better predict the effects of non-continuous cutting forces caused by dynamic changes in cutting speed. Kyle Odom is also a master's student working in the ARMS Lab. Kyle's interests include dynamic systems modeling, computer-aided design and manufacturing, and control systems. Kyle's current research is devoted to developing an orthogonal and oblique cutting simulation using the finite element package Abacus. Once an accurate and flexible model is developed, his cutting simulation will be integrated with the machine tool spindle control system subroutine. In addition to research and graduate student positions, the ARMS Lab also offers several positions for undergraduate engineering students during the academic year and summer season. There are currently 4 dedicated and determined engineering students working in the lab who assist with the ongoing research projects and activities. They are Jeremy Jacobs, Esteban Almazan, Michael Starr, and Christian Young. While working in the ARMS Lab, the undergraduate students are exposed to ongoing research projects and given the opportunity to advance their knowledge and understanding of manufacturing processes. Students have access to the latest CAD, CAM, and CAE software. And through mentoring relationships and training, the undergraduates can learn to operate and program 3-axis machine tools and gain experience working in the laboratory to collect and analyze data from cutting experiments and FEM simulations. The ARMS Lab's recently furnished office provides a comfortable and professional working environment for lab members, offering a dedicated space for meetings and collaboration. Along with the workspace and computer stations, lab members have access to a suite of software programs to aid them in their research duties. Along with our office space facilities, Boehner Hall houses the large DMG Moriseki NV7000 3-axis vertical milling machine. The NV7000 is used to cut hard-to-machine materials like titanium alloys and nickel-based superalloys. Of particular interest is the modified spindle system developed by Professor Soshi, which has been installed on the lab's machine. While working at Moriseki, Professor Soshi developed a high-torque, high-power spindle system equipped with a synchronous motor for high-performance cutting of difficult-to-machine materials. The high-torque, high-power spindle system was fabricated from a permanent magnet synchronous motor coupled to a pulse-width modulator driver. An updated version of this high-torque, high-power spindle system has been installed on the ARMS Lab's NV7000, providing the lab with the ability to test various cutting conditions as influenced by the dynamic characteristics of the spindle system, which can be modified and tuned by adjusting the gain of the controller. Thanks to the open-source controller algorithm, the controller parameters can be easily modified to achieve maximum spindle performance, or the parameters can be adjusted to study the influence of spindle response on machining processes. The NV7000 is primarily used to cut hard-to-machine materials like titanium alloys and nickel-based superalloys. However, most recently the machine has been used to characterize tool wear when machining hardened cast iron during a feasibility test of a new production process. Additionally, the ARMS Lab has access to an array of measurement devices used to document machining experiments. These include a high-speed camera by Photron, spindle dynamometer by Kiesler, an accelerometer by Onosoki, radiation thermometer by Tokyo Seiko, a multi-channel data logger by Yokogawa, a power meter by Yokogawa, and a surf test by Mitutoyo. The majority of these measurement devices can be used together simultaneously to log different aspects of the machining process in real time, as shown in the following video of a face milling operation. The ARMS Lab is developing a model of the cutting process using the finite element method. Our primary motivation is to build a simulation which can shed light on the connection between the micro and system scale, highly dynamic processes that occur during metal cutting. We are using the Abaqus Explicit software package to develop our own finite element model. In addition to the orthogonal and oblique cutting simulations in Abaqus, the ARMS Lab is also working to incorporate a subroutine that would incorporate a PI speed controller into the FEM cutting simulations. A commanded cutting speed would be input into the program, where an actual cutting speed would be calculated from the previous operation. The speed controller would then compute and adjust the cutting speed, with the adjusted speed being fed into the FEM cutting simulation, and the speed change after the cutting event exiting the program. Thank you for watching our video. Please check out our website to learn more about our ongoing research.